Good morning, students. And today I will teach differentiation. Okay, that is derivative of a function. Already in previous class, in live class, already discussed continuity. Now, all of you know continuity. Okay, so right, differentiation. Right, differentiation. Suppose y equal to f of x is given, be a real world function given, then we can write dy dx, okay, dy dx equal to, so limiting from limit h tends to 0, f of x plus h minus f of x by h, okay, note it down, dy dx equal to limit h tends to 0, f of x plus h minus fx by h. Okay, where here h is the increment of x. H is the increment of x. Suppose, say the value of x will be suppose 1 is given. This is suppose initial value. This is suppose initial value. Okay, initial value. And the value suppose 1.001. So this value is final value. Okay, so their difference, so you can write delta x, so will be 0.001. so you can write this also x increment of x, that is delta x or h you have to write. Okay, so keep in mind delta x not equal to delta into x. Okay, just only one change of x. Okay, the change of x, only write delta x or h. This is increment of x. Okay, and suppose this is final value, this is initial value. We are consider, suppose this is x0, consider this is suppose x1. Then delta x equal to x1 minus x0, that is h equal to x1 minus x0. So x1 we can write, so x0 plus h. Okay, now y is the function of x, so initial value of y we can write f of x0 and final value f of x1. The delta y equal to f of x1 minus f of x0. Okay, so this can be written as f of x0 plus h minus f of x0 delta y. So you write delta y delta x, you can write f of x0 plus h minus f of x0 by h. Okay, if delta x tends to 0, that is very closed, tends to 0, 0.001, 0.0001 is there, very close value is there. Okay, that is tends to 0, that is limit we can write, suppose delta x tends to 0, this ratio delta y delta x equal to, so limit h tends to 0, f of x0 plus h minus f of x0 by h. If the limit exists, this limit, that is limit x tends to 0, delta y delta x, we can say dy dx equal to limit h tends to 0, here consider x0, we consider x, then f of x plus h minus fx by h. Here dy dx, don't take dy dx, keep in mind not equal to dy divided dx. Okay, dy dx not equal to dy divided dx, keep in mind. Now dy dx, limit h tends to 0, f of x plus h minus fx by h. So this is called the first principle of derivative. This is called first principle of derivative. Okay, see, So y equal to f of x. So we are getting now dy dx equal to f dot x. Okay. So this can be written as, see, suppose L f dot x. This is R f dot x. So limit, this will be limit h tends to 0 minus f of x plus h minus fx by h. Here limit h tends to 0 plus f of x plus h minus fx by h. Okay. When a function is said to be differentiable, when a function is said to be differentiable, a function is said to be differentiable. Suppose the point x equal to a. Suppose r f dot a equal to l f dot a, where r f dot a equal to, keep in mind, limit h tends to 0 plus f of a plus h minus f of a by h, and l f dot a limit h tends to 0 minus f a plus h minus f of a by h. Okay. So keep in mind, a function is said to be differentiable at x equal to a if right hand derivative at x equal to a is equal to left hand derivative at x equal to a, and both are equal. Okay, both are equal. Now with the first principle, derivative first principle process, okay, find dy dx or f dot x. Okay, so this is very important question is there. Suppose find dy dx with the help of derivative first principle. Okay, I am showing how to solve. Look at the board, all of you look at the board. Suppose given y equal to f of x, so dy dx given, suppose x square is given, find dy dx with the help of first principle. So write first f of x plus h, right? So x plus h whole square. So dy dx, all of you know the formula, limit h tends to 0 f of x plus h minus fx by h. So write limit h tends to 0, so x plus h whole square minus x square by h. So limit h tends to 0, x square plus 2xh plus h square minus x square by h. Both x are cancelled. So write limit h tends to 0, take h common, 2x plus h by h. So this is cancelled. If put h equal to 0, this will be twice x. Okay, right. So here we are getting d dx, see, x square getting twice x. So all of you remember general formula, d dx x to the power n x to the power n minus 1. Keep in mind, x to the power n, here x is here, x to the power n, okay, n x to the power n minus 1. Okay. Now similarly, if we write suppose d dx of x cube, so we can write now 3x square d dx x to the power 4, we can write 4x cube. It's like that. Suppose d dx x to the power 3 by 2, we can have 3 by 2 x 3 by 2 minus 1, that is half. Okay, all of you remember the process. again see, suppose f of x equal to root x. So f dot x find out with the help of first principle. Okay. So write f of x plus h. So write root x plus h. Root h. No, like that, root x plus h. So f dot x, write formula, write f limit h tends to 0, f of x plus h minus fx by h. So write limit h tends to 0, root x plus h minus root x by h. So write limit h tends to 0. Okay, just have rationalized. So here x plus h minus x by, you can write now, h root x plus h plus root x. Both numerator and denominator you have to multiply it by root x plus h plus root x. Then a minus b, a plus b, it will be a square minus b square. So that x plus h minus x by h root this. See, both h cancel. So here x cancel here. So limit h tends to 0. H cancel 1 by root x plus h plus root x. Now put h equal to 0. 1 by 2 root x. This is the answer. Just note it down. Suppose again fx equal to e to the power root x. Should I f of x plus h? You can write e to the power root x plus h here. So f dot x you can write limit h tends to 0, f of x plus h minus fx by h. Okay, so write limit h tends to 0, e to the power root x plus h minus e to the power root x by h. So you can write limit h tends to 0, e to the power root x common. So e to the power root x plus h minus root x, here minus 1 by h. See, you can write. Now limit h e to the power root x you take outside, this one take outside. So limit h tends to 0. Now e to the power root x plus h minus root x minus 1 by, you write whatever is given here, you write down this one into, so this part. See, after that, no, look at here, into limit h tends to 0. Wait, see, here, no, like that, this part you have to write. See, h tends to 0 into, right here, okay, into limit h tends to 0, root x plus h minus root x by h. Okay, so this part, if this suppose the constant, this is suppose p, if h tends to 0, then whole part also 0. Okay, this part. So right here e to the power root x limit p tends to 0, e to the power p minus 1 by p. Okay, into, here similar way we will get this part 1 by 2 root x. So write 1 by 2 root x. Okay, so e to the power root x by, here, by 2 root x. This is the answer. Note it down. Okay, e to the power root x by 2 root x. Suppose say f of x equal to sin x. So f of x plus h, similar way sin x plus h you can write. So write dy dx equal to limit h tends to 0 f of x plus h minus fx by h. So write limit h tends to 0, this part sin x plus h minus sin x by h. So write limit h tends to 0, sin से मैंने sin formula applied, 2 cos c plus d by 2, all of you know sin से मैंने sin formula, all of you remember this formula, sin c minus d, that is x plus h minus x by 2 by h is given. So write limit h tends to 0, 2 cos here 2x with x plus h by 2 into limit h tends to 0, right? Here sin h by 2 by h is given. Okay, so you can write 2 into h by 2. So this 2 and this is cancelled. Just you put here h equal to 0 here, so it will be cos x into limit h tends to 0, all of you know sin h by 2 by h by 2 1, so write into 1 equal to cos x. So we are getting d dx of sin x, look at here. Okay, so we are getting d dx of sin x equal to cos x. Similarly, you are getting d dx of cos x equal to, you are getting minus sin x. Same formula. Okay, same with the help of first principle. Okay, we are getting, it will be d dx cos x minus sin x. Similarly, d dx of, keep in mind, tan x equal to will be sec square x. d dx cot x, we are getting minus cosec square x. d dx sec x will be sec x into tan x, and d dx cosec x, so minus cosec x into cot x, all of you remember. Okay, and d dx, suppose e to the power mx, m e to the power mx, d dx a to the power x, we are getting a to the power x log a. Okay, d dx, suppose log x 1 by x, d dx any constant term, keep in mind constant term will be 0, keep in mind d dx constant term. Okay, d dx any constant, it will be 0. Okay, now all of you remember the formula, many formulas are there. Okay, so another I am showing d dx, suppose sin inverse x 1 by root under 1 minus x square, d dx cos inverse x, so minus 1 by 1 minus x square, d dx tan inverse x 1 by 1 plus x square, d dx cot inverse x minus 1 by 1 plus x square. All of you remember this formula, d dx sec inverse x 1 by x root x square minus 1, ddx cosec inverse x 1 by minus 1 by x root x square minus 1. Keep in mind. Always remember this one. Okay. Note it down. Okay. Now. So wait. Suppose ddx, look at here, fx equal to sine inverse x. Okay. Suppose I write f of x plus h sine inverse x plus h. Suppose this is write u, so this part will be write u plus k. Okay. So limit h tends to 0 f of x plus h minus fx by h. All of you know the first one formula. Okay. Just write here limit h tends to 0 x plus h means u plus k, right here u plus k minus fx u by h. So you cancel now. So limit h tends to 0 k by h, you can write here x plus h sine u plus k, and here x equal to sine u. Clearly h tends to 0 implies k tends to 0. Put here h plus x, the value of x will sine u, so sine u plus h equal to sine u plus k. So if h tends to 0, then we can say k tends to also 0. Keep in mind. Okay. K tends to 0. Now h you can write sine u plus k minus sine u. You write here k tends to 0. Okay. Now so this part you can write 1 by limit k tends to 0 sine u plus k minus sine u by k. So 1 by limit k tends to 0, you put sine c minus sine formula applied. Similarly it will be cos u will come. Okay. Here so 2 cos u plus k plus u by 2 into sine u plus k minus u by 2. Okay. Now write 1 by limit k tends to 0 by k is there. Wait 1 minute by k. Now 2 cos u plus k by 2 into limit h tends to 0, sorry, k tends to 0. Okay, k tends to 0 sine k by 2 by, you can write 2 into k by 2, this to cancel. So the all of you, this is 1. Now 1 by cos u, so you can write 1 by root 1 minus sine square u. So 1 by root 1 minus x square. Okay, sine equal to x, you know, so it will be 1 by root 1 minus x square. All of you remember this one. Okay. So all of you remember that formula, various type of formula is there. And next class I will discuss also when a function having derivative at a point, then it is must be continuous. But continuous function may or may not be differentiable. Differentiable function must be continuous, but continuous function may or may not be differentiable. Next class I will discuss this one, and also few formulas also there. That is product rule, quotient rule I will discuss. Then you can complete this one, and the condition of differentiability also there. Okay, bye.